In this video, we will learn how to count the number of possible ways to organize 2 and 3 segment domino tiles for a given size board. We will do this in linear time complexity. Hello and welcome to the Python implementation of LeetCode problem 790, Domino and Tromino tiling. The problem states you have 2 types of tiles, a 2x1 domino shape and a Tromino shape. You may rotate these shapes. Given an integer n, return the number of ways to tile a 2 by n size board. Since the answer may be very large, return it modulo 10 to the 9 plus 7. In a tiling, every square must be covered by a tile. 2 tilings are different if and only if there are 4 directionally adjacent cells on the board such that exactly one of the tilings has both squares occupied by a tile. For example, example 1. Input n is 3, output is 5. Example 2. Input n is 1, output is 1. The constraints are the possible board widths is between 1 and 1000. What this is really asking is, we are given a number n representing a number of rows in a game board. We have domino tiles and Tromino tiles, both of which can be rotated. You want to see how many ways you can place and arrange tiles to fill a certain size board. Since the number of tiling combinations grows exponentially with the board size, the total number of combinations may be huge. So, to prevent an integer overflow error, the problem asks that we constrain our counting within some range, modulo. This is a dynamic programming problem. We can guess this because it does not work on a linked list, graph, or range. It does not find a target value, minimum, or maximum. It has small bounds. And it has an inefficient iterative solution. If you're serious about acing coding interviews, I've got something that will help. Sign up for the LeetKey newsletter and get weekly LeetCode problems, detailed solutions, and proven strategies straight into your inbox. Now back to the video. You might find this type of problem in other fields, including population growth. For example, a species where individuals become fertile in their 3rd year and live exactly 3 years. The number of births in this year comes from the cohorts aged 1, 2, and 3 last year. Finance and accounting. For example, the rolling 3-month net cash is equal to the inflow of cash from the last 3 months. This is called an accountant's quick KPI. Or manufacturing and supply chain. For example, a work cell whose throughput today equals parts released from 3 upstream cells finished 1, 2, and 3 shifts ago. For example, curing, cooling, inspection on each shift. You might be inclined to solve this problem by iteratively generating tile combinations and checking if each placement fits or does not fit. But this approach requires exponential time complexity since it requires a nested loop, and it requires collision detection, which is relatively complicated to implement. A more optimal approach is to iterate over each smaller board size and use dynamic programming to store the number of new combinations available with each change in board width. At each turn, we can count the number of ways we can tile pieces within that board size. We notice that as we increase the width of the board, we can rotate and swap the positions of dominoes and rotate the Trominos. Therefore, as the board gets wider, we double the number of domino tiling options and add an additional rotation for each paired Trominos. This solution leverages the knowledge gained from each board size, resulting in a linear time complexity. Let's see how to implement this solution. This solution works by counting the combination of orientations of tiles for a given board width. The problem requires we track our progress within a specific range, so we define that value. There can only be one way to tile an empty or one squared board, and two ways to tile a two-square board, which is why we return these values if n is 0, 1, or 2. For larger boards, we calculate the possible orientation of each additional tile up to n. The new width adds double the combination of dominoes and one combination of Tromino. To constrain the size of the result, we restrict it within the range as requested. We update each combination count with its next value. We continue this for the remaining board widths. When the loop finishes, C represents the total tiling combinations for an n-width board. The space complexity for this implementation is static, since we reuse the three variables that count the number of tiling combinations. The time complexity for this implementation is linear, since we must iterate from 1 to the target board size to find the number of possible tiling combinations. That was how to solve LeetCode problem 790, Domino and Tromino tiling. Thank you, Zenis, for subscribing. Next week, we will be looking at problem 338, counting bits. So subscribe and click that bell to get notified when that drops. Let us know in the comments which problems you'd like to see next, and please share this video with any programmers or aspiring coders you know that you think would benefit from its insights. It's word-of-mouth referrals like yours that really help this channel grow. You can get this video a few days earlier, plus other exclusive content from our Patreon.